So in this video, we are going to be looking at product rule differentiation. We'll discuss the formula and then we'll dive in straight into solving examples. Now, let's say y is equal to u times v, where u itself is a function of x and v as well is also a function of x. So this actually makes y a function of x. Now, if that's the case, how then do we find the y all over the x? How do we find the y all over the x? So simply, when two functions or two terms are multiplying themselves and each of these terms are a function of x, then how do we differentiate? Now, this is what we do. In differentiating two terms multiplying themselves, the first thing you do is hold the first term a constant. So I will keep u a constant. Now you differentiate v with respect to x, plus now you hold v being the second term a constant, then you differentiate u with respect to x. If you do this, then you have satisfied the product rule. Now let's pick an example to illustrate this. Now let's say we are given that y is equal to x to the power of 3 multiplies 3x squared plus 2, and we're asked to find the y dx. Now you have the liberty to either expand this equation and solve using the power rule, or you can simply solve by the product rule. But since we are learning by product rule, let us simply use the rule. So by product rule, what do? You simply say let u be equal to x to the power of 3. So this simply implies that v will now be equal to what? The remaining variable there, which is 3x squared plus 2. Alright, so having this now, it means that this equation can now be written in form of the original equation for product rule. That is simply saying that y can simply be equal to, in place of x cubed, we call that u times, and in place of 3x squared plus 2, we call that v. So which means this becomes now a product of two functions, and as such, we are going to be employing the product rule to solving this problem. Now by product rule, remember the formula above. What do? We simply differentiate differentiate v with respect to x, also differentiate u with respect to x. That's all we are doing. Then multiply them interchangeably using u and v. All right, okay, so from u is equal to x to the power of 3, we simply employ the power rule. Therefore we differentiate u with respect to what? X. From the power rule, remember in our previous video we did a video on power rule. I'll simply drop the link of that video in the description of this video so you can watch out for proper understanding. But in the power rule, I simply say use the power of the variable to multiply the variable, then subtract 1 from the power. So in this case now, the power of x is simply what? 3. So I'll simply have 3 multiplying by what? X to the power of 3. Subtract 1 from the power, minus 1. So this simply implies that du all over the x is going to now be equal to what? That becomes 3x to the power of 2, because 3 minus 1 is 2. So du dx is simply 3x squared. We are simply going to employ the same thing to differentiate v. So from v equals 3x squared plus 2. Okay, this simply implies now we differentiate v with respect to x. So this is going to be equal to, now employing the power rule, remember 3 there is a constant, so you pull it out. Let's now differentiate x squared using the power of x, which is 2, to multiply x. So I have 2 multiplied by what? X all squared, then subtract 1 from the power, minus 1. Close your bracket. Plus, now this is 2. 2 there simply means, let's just do a little thing up here. 2 can also be written as 2 is same thing as saying 2 times x to the power of 0. where any variable to the power of 0 is simply equal to 1. So you have 2 times x to the power of 0, which still means which implies that x squared is actually, which implies that x to the power of 0 is actually 1, and 2 times 1 still gives us 2, right? So that means if I'm going to be differentiating 2, this is what happens. I'll have 2 multiply now by, remember you use the power of the variable to what? Multiply the variable. So x now is to the power of 0, therefore I will simply have 0 times x, right? Then subtract 1 from the power, 0 minus 1. Now if you do this, you notice that 0 times x is 0, 0 times 2 is 0. So which means if I differentiate 2, the value is simply 0. So keep this in mind. Whenever you differentiate a constant, you always have the result to be 0. So this simply means plus, if I differentiate 2 here, the value gives me 0. Okay. Now from here we can simply have dv all over the x to now be equal to, so from this side, this is 3 times 2 here, that gives us 6. X to the power of 2 minus 1 is 1, so that becomes 6x. So therefore dv dx is actually what? 6x. So I have the result to be 6x. Now having found dv dx and I found du dy, you recall that from product rule, the y all over the x is equal to what? Remember, keep u constant, differentiate v with respect to x, plus now you keep v constant, differentiate u with respect to x, which we have done. So therefore this simply implies that dy all over the x is equal to, so holding u constant, remember we said let u be equal to x to the power of 3, as can be seen here. So hold u constant, and u is simply x to the power of 3. Now multiply by dv dx, and dv dx gave us here as what? 6x. So multiply by 6x. Close your brackets, plus now you keep v constant, and not forgetting from here v is simply 3x squared plus 2, so you keep it constant. I have 3x squared plus 2, okay, 3x squared plus 2. Now you multiply by derivative of u with respect to x, and when we differentiated u with respect to x, we had 3x squared over here, so which means to multiply through by 3x squared. So multiply by 3x squared. Alright, so let's try to expand this and see. This means that dy all over the x is equal to, if we expand this bracket, 6x multiplied by x to the power of 3 gives us 6x to the power of 4, plus, now let's expand this other bracket, 3x squared multiplies 3x squared, that simply gives us 9x to the power of 4, plus similarly 3x squared multiplied by 2, that simply gives us 6x squared, right? Okay, so I have 6x to the power of 4 plus 9x to the power of 4. 6 plus 9 simply gives us 15x to the power of 4, plus you put down 6x squared, and this becomes the result of that derivative using product rule. Now let's try one more example. Now let's say we are given y to be equal to sine x times cos x, and we are asked to find dy dx. Remember the product rule, okay? So we have two terms now multiplying one another. So you simply say let u be equal to sine x. Mind you, you can also say let u be equal to cos x. It doesn't really matter any order you choose. So far they end up multiplying one another. That's the most important thing. Okay, and v equals cos x. If this happens, this simply now implies that y itself is equal to, in place of sine x we call that u, times in place of cos x we call that v. So you see now that this is a product of two functions, which means we are going to be employing the product rule. Now, without setting the formulas, let's simply solve. Let's just simply solve it together, right? So the y dx is going to be equal to, remember, keep u, and u is sine x times differentiate v with respect to x. If I differentiate cos x with respect to x, I will simply have what? Minus sine x. Okay, plus, now you keep v, and v is cos x. Then you differentiate u with respect to x, and u is sine x. If I differentiate sine with respect to x, I will simply have what? Cos x, and you have this. So this simply implies sine x times minus sine x, that gives us minus sine squared x, plus cos x times cos x, that simply gives us what? Cos squared x. So this becomes, you can simply rewrite this. This simply implies that the y all over the x is simply going to be equal to, if you rearrange, you have simply cos squared x minus sine squared x. Alright, so this becomes the final answer of that question. Okay, so that's it on product rule for now. In the next video, we're going to be solving multiple examples involving trigonometric functions, exponential functions, and so on and so forth in product rule. I'm sure you want to be a part of that video, so do well to smash the subscribe button right now, turn on your notification bell so you don't miss out on that video when it drops. In the meantime, do well to like this video, share it to your friends, and comment nicely. I will see you in the next video. Thanks.